Hello, students, and welcome for the MD2 lecture series. So, we are continuing the theory session of belt drive, different type of drives. Normally, we are discussing here the belt drive, V belt drive. Okay. So, previously, we have seen in the last two lectures regarding the different type classification, important parameters, factors while selecting the belt drive, materials of belt, then various formulations. Okay, so length design. Okay, and those things we have seen. Now we are continuing with the design of pulley, that is through the material of cast iron. So generally we have seen the material used for pulley is cast iron, steel, that is pressed steel, wood, and rubber. Okay. So the dimensions which we calculated by using some empirical relations. Now the failure of the pulley diameter is done because of the centrifugal forces acting at the pulley. So tensile stress is equal to rho into V2. That is nothing but the density of ring material. If we are using casting material, it is 7,200 kg per meter cube. And the velocity of ring that we can calculate by pi d n by 60, where d is the diameter of pulley and n is the speed of pulley. So from this equation, you can find out the stress induced. Okay. And the standard dimensions or diameter of the pulleys are available with the flat welder and V welder as mentioned here. It started from 20 diameter to 5,400 diameter. And these one from 20 diameter to 36 diameter, that is the first six sizes, are generally used for V belt drive, not for flat belt drive. So the flat belt drive dimensions will be start from 40 onwards. Okay. Then to calculating the width of the belt, capital B is nothing but generally when the width of the pulley or a face of the pulley is taken 25% greater than that of the belt width. So the capital B, that is a, or you can say, you can indicate a B in suffix of pulley P. So that capital B is equal to 1.25 times of belt width. Okay. As per the Indian standard, some width, the belt width has been given and the width of the pulley to be greater than the width. How many it should be exceeded. So up to 125 diameter of the belt width, we need to increase, or you just add 13 width, so your belt can be easily mounted over there. Okay, so similarly the details as given. So up to the 500 we need to add 50 exceeds. Then for mild steel pulleys, the width of given, it starts from again 16 to 630 because the manufacturing of these pressed steels are quite difficult. So generally we are using cast pulleys. The thickness of the pulley rim varies from D by 300 plus 2 to D divided by 200 plus 3 for single belt, and for double belt it is D divided by 200 plus 6. Okay, this is a generic empirical relation we can use for calculating the thickness of the pulley. Then dimensions of arm. So first of all, we need to identify number of arms. Previously, we have seen a chart where based on the diameter, the number of arms has been suggested. So in general, you can consider 4 arms for diameter from 200 to 600 and 6 arms from diameter of 600 to 1500. So if the pulley is lesser than 200 mm, then a solid disc inserted in the arms and the thickness of the solid wave is taken equal to the thickness of the rim measured at the center of the pulley face. Okay, we are using here the solid disc, okay, rather than arms. So next one, the cross section arm. So what kind of cross section is used? Can we use square, rectangle, elliptical, trapezoidal? So here we are generally suggested to use uh, elliptical type of cross section for arm design, having major axis A1 equals to twice of minor axis B1. The cross section of arm is obtained by considering arm as a cantilever beam that is fixed at the hub end and carrying a concentric load at the rim end. The length of the cantilever is taken equal to the radius of the pulley, and then further assume that any given time the power is to be transmitted from hub to the rim and vice versa through only the half of the total number of arms. So if you consider 4 arms, only 2 arms will be engaged to transmit the power. Then some load calculations we need to do. So torque or tangential load we can calculate by using torque transmitted divided by radius of pulley into the number of arms by 2. Okay, so it is nothing but the equation will be get is simplified 2t divided by r into n, and the maximum bending moment which we can calculate it at the arm. So it is again we need to multiply that tangential load with the by radius, that is a distance. So equation get 2t divided by n. Okay, then section modulus, as we are using elliptical, the value of section modulus z is equal to pi by 32 into b1 into a1 square. Okay, so by using these equations you can calculate the loads acting on the arm. The arms are tapered from hub to rim. The taper is that taper value is usually 1 by 48 to 1 by 32, and the width of the pulley exceeds the diameter of the pulley, then 2 rows of the arms are provided, which is shown in figure number 20, to avoid the heavy arm in a single row. So as we applied number of rows, it will carry load separately, and rather than what you can say the heavy arm, we are using 2 lighter arms for same configuration. Then dimension of hub, it is generally the empirical relation is given. So d1 is equal to 1.5 d plus 25 mm, or in it should not be greater than the 2d. Okay, so whatever the diameter of the shaft, it should not be the value of hub should not be greater than the 2 times of diameter of the shaft. Then the length of hub is equal to pi by 2 into d, that is the diameter of the shaft. The minimum length of the hub is 2/3 of width of pulley. Okay, it should not be exceed than that. Now V belt, as we know that the V belt is mostly used in a factories and workshop, where the great amount of work, great amount of power is to be transmitted from one pulley to another pulley, and the center distance is less. These V belts are generally made from fabrics and cords. You can refer figure number 21, section figure number A. The fabric and cords modulated with the rubber and converted with the fabric and rubber, that we can see the layers are different. So rubber layer, then cord layer, and then above fabric layer, and above that, the final layer is a fabric plus rubber cover. The inclination angle of the V-belt is usually from 30 degree to 40 degree, and power transmitted by the wedging action because it is connected with the ends side walls. So wedging action between the belt and V groove in the pulley and sleeve. The wedging action of the V belt in a groove of the pulley results in a higher force of friction. Here the little consideration will be shown that the wedging action and transmitting torque will be more if the groove angle of the pulley is smaller. If the groove angle of the pulley is smaller, then the contact area will be more and more force will be transmitted with the less power loss. Okay, and here that because of that the friction will be more and wear also get more. As the groove angle is promising between two, usually the groove angles in between 32 degree to 38 degree. Now a clearance must be provided at the bottom of the groove, which is shown in you have seen in figure number 21b, because there is some gap should be there so that the air can be passed and it can be cooled. Okay, and in order to prevent the touching of the bottom as it becomes narrow from width, so the wear could be increased. Okay, and the V-belt drive may be inclined at any angle with the tight side, either at the top or bottom. In order to increase the power output, several V-belt drive may be operated by side, and it may be noted that the multiple V-belt drive, all belts should be stretched in the same rate so that the load is equally divided in between them when we are going for multi-belt V drive. When one of the set is bends, break, the entire should not be replaced. Only the same broken belt will be changed, so the operation will not be stopped at immediately. Okay. If only one belt is replaced, then new owned and unstretched belt will be more tightly stretched and it will be moved with a different velocity as the tension in between that material will be different. So few types of V belts and pulleys according to Indian standard. There are 5 types: A, B, C, D, E, having based on the power ranging. It starts from to 0.7 to 350 kilowatt. So as they have prepared a cross section. So based on that, the types of V belt is done. Okay, so the ranges are given over here. You can refer. Now the standard pitch length for V belts. So as the cross section changes, there is a change in pitch will be occur. Okay, so for each cross section we have mentioned in a table that what could be the range they can use for our power transmission purpose. Okay, so pitches are given and all pitches are different to each other. Okay, if you look at the values. Then standard pitch length of the V-belt. The V-belt also manufactured in a non-standard pitch length, that is oversized or undersized. The standard pitch length belt is designed by the grade number 50. The overbelt are designed by grade number more than 50 and undersized designed by lesser than the 50. It means that the 1 unit of the grade unit represents 2.5 mm inner length from the normal pitch length. We will discuss an example. If the V belt marked A914-50, it denotes that the inside length of the belt is 914 mm and pitch length is 950. Okay, so a belt mark with A 914-52, it is oversized as we discussed. If it is a 50, then it is a regular one. If greater than 50, then it is oversized, and less than 50, it is undersized. So it is oversized by 2 units of the grade number. That is a difference between 52 and 50 is 2. Since the unit of grade number respects 2.5 mm, therefore the value of this is nothing but 2 into 2.5, that is 5 mm, which can be added into the internal pitch length, that is 950. Okay, so based on the different marks, you can identify the oversize and undersize, and how much it is oversized and how much it is undersized. Okay, now the ratio of driving tension for V belt. While calculating the belt, we need to identify the tensions which is generated inside. Okay, so R1 is the normal reaction between the belt and side of grooves. R is the total reaction in the plane of groove, which can be shown in figure number 22. Then mu is the coefficient of friction between belt and side of the grooves. Then for resolving reaction, R is equal to R1 sine beta plus R1 sine beta. Beta is nothing but the 2 beta is nothing but the angle between two side walls. Okay, so from that you can find out the value of R1, that is R divided by 2 sine beta. Now from the frictional forces, we can calculate friction force, that is equal to twice mu into reaction, that is R1. Okay, so you can find out the value, that is mu R1, put the value of R1. So what we get, mu R1 cosec beta. Okay, 2 sine beta is nothing but cosec beta. So you can find out the values. Sine 1 upon sine beta is a cosec beta. So considering a small portion of the belt subtending an angle of delta, so there is a variation in angle at the center. The tension on that side will be T, on the other side will be T plus delta D. Now we can directly find out the relation based on the logarithmic way, or log, considering the log 2.3 log of T1 plus T1 divided by T2 into mu theta cosec beta. So in this way you can find out the tension in V belt drive. Now we need to identify advantage, disadvantages of, or you can say comparison between V belt drive and flat belt drive. So first of all, discuss the advantages of V belt drive over the flat belt drive. So first one, the V belt drive gives the compactness due to the small distance between the centers of the pulley. It is very compact in design. Then this drive is more positive. It can transmit more torque, and it having negligible slip in between belt and pulley as compared to the flat belt. So V belt are made endless and there is no joint. So therefore the operation will be smooth, no fluctuating noise will be there. So another, it provides longer life up to the 3 to 5 years. As we know that if joints are not there, then the failure, chances of failure will be reduced. So the life of a V belt drive is more than that of flat belt drive for same range. It can be easily installed and removed. The operation of V-belt and pulley is quiet. It couldn't provide much noise as like a flat belt. The belts have the ability to caution the shock and then the machine to be when machine is start. So it can absorb the shocks. When machine start, it suddenly start transmitting. So there is a chance of creating the vibration or you can say shock. So that can be absorbed by the various layers in while we manufacturing in V-wheel design. The materials which are used in V-weld are shock, rubbers, and fabrics, so it can absorb the shock. The belts are have ability. Sorry, the belt drive is normally used for high velocity ratio. Okay, rather than flat belt drive. The wedging action of the belt in the groove gives a high value of limiting ratio of the tension. Therefore, the power transmission by V belt is more than the flat belt for same coefficient of friction, arc of contact, and allowable tension in the belt. The V belt may be operated in one direction or two direction because the tension in both top and bottom sides are equal, linearly equal, and the center may be horizontal or vertical or inclined. It can be used in both direction. Then few disadvantages are there over the flat filter. We cannot use for larger distance because the weight per unit length will be get increased. Okay, if you compare the cross section, the thickness of the V belt is more as compared to the flat belt. Now V belts are not durable as the flat belts. Um, Durables means it cannot be used for long run. Okay, so durability of the V belt is very less as compared to the flat belt. We cannot. It is endless, so we cannot use again and again. So it is the basic drawback of V belt drive. If it is loosened once, we just need to replace. And flat belt drive, we can increase the chain or can say joint. We can just cut down the exceeded length and again we can join the ends and we can use. So that drawback is having with the V-build truck. The construction of pulleys for V-build is more complicated than that of the pulley of the flat belt truck. Okay, so we have to introduce grooves. We have to provide the grooves with a particular angle. Okay, if it is not in a particular angle, so there is a possibility of the friction and etc. But in same case, if grooves are particularly engraved, so it means that we have to prepare a special type of casting, or you can go with the machining to achieve the proper surface strength. So that's why the construction of the pulley of V-build is more complicated. V-builds are subjected to certain amount of creep. Therefore, these are not suitable for constant speed application, such as synchronous machines, time devices. Okay, so creep is occurred due to the fluctuation, contraction, and expansion of the belt. So because of that, this stresses on the wall can be occurred, and there is a possibility due to creep. If we are using continuous in operation, there is a possibility of generation of the cracks. Okay, so that's why it can be failed without intimation. The belt life is greatly influenced with the temperature changes improper belt tension, and mismatching the belt lengths. Okay, these are the important points. The centrifugal tension prevents the use of V belt at the speed below 5 meter per second and above 50 meter per second. Okay, so that's it about the theory of belt drives. We have covered the advantage, disadvantages, comparison between V belt and flat belt. Also, we have covered the design aspect, how we can select the materials, which are the materials used, then what are the formulas we can use for design. Okay, so all the theory part is covered in this third lecture of theory. So if students you have any kind of doubt, you can contact me. Okay, so we in next lecture we will discuss numerical on design of a flat belt drive. Okay, thank you very much for joining. In a description box I will share the previous two lectures video as well as the theory notes. Okay, thank you.